happens. So, two activities at the beginning and the end of a course. The goal is creating career connections in the curriculum. So, going along with the theme of shameless plugs, this was a spinoff of the Biomedical Engineering Division's Education Showcase. So, very quick presentations for teaching tips, and there's applications for those now. But this is sort of maybe like a deeper dive on one that I gave last June. So some of it may be familiar and some of it is going to be a little bit new, but hopefully a good opportunity to get some discussion, and you guys can give me just as many ideas as I give you here. So some of the objective really is this activity that I'm going to explain is a pretty low barrier to implementation. It's going to take hopefully a little bit not so much effort, but a strategy that's going to do multiple things. And one of it is just designing aspects of a course to target BME industry relevant skills. A kind of secondary goal is to help educate students about career titles and options in BME, and then also motivate students to learn course objectives by linking those to industry skills. So I'm going to give an example, but I want to kind of provide the context for the course that I do this in. So I teach a roughly junior level class. There can be late sophomores or even graduating seniors in this class, but it's for biomedical engineers to do hands-on laboratory experiences. So it does focus on some hands-on skills and equipment like aseptic technique and cell culture using microscopes and image analysis, spectrophotometry, micropipetting, using mechanical test frames, using ultrasounds for different applications, and all the measurements related to that. But there is also a large aspect related to technical writing and communication. So a lot of their grade is related to their lab notebook documentation, writing a scientific style article, and doing oral presentations. But then another aspect of the course is statistics and data analysis. So really the only prerequisite to this class is they are in BME and they have taken a statistics class. So from that, we do a little bit of experimental design as well. And that at the end of the semester, students will actually develop their own experiment. So on the first day of class, some students don't know exactly what to expect for the course. So I do, a typical syllabus day, but part of that is I show this ad. So I give them the instructions, read through this job description, and ask yourself, do you feel qualified for this job? So I'm going to actually let you guys kind of read through this kind of skim through at that level. So you might have skimmed really quickly. I'm kind of a slow reader, but it's okay if you didn't read all of it. But I point out this is a real job. This is called a quality engineer too. Biomedical engineering is not really in the title. This is also an entry-level job. So this is a job where someone with a bachelor's degree in biomedical engineering right after graduation should be able to get. I don't say that necessarily, but I do ask them this question on Top Hat. So I ask them, do you feel qualified for this job? And they have an option of yes, maybe, and no. So I save those responses, and this is typically what I see on the first day of class as far as how many people answered yes. Sometimes it's 3. Maybe those are the graduating seniors there. There's a good chunk of them that say maybe, and a pretty good chunk of them that say no. But then I show them the same ad on the last day of class. I ask them the same exact question, and these are sort of the typical responses that I get on the last day of class. So a lot more of them say yes. Some of them still say maybe, and maybe 1 or 2 people say no. I usually also take this as an opportunity to kind of dive in and reflect on what did we do in this class. but also point out that you should never necessarily feel 100% qualified for every job that you apply to. There are some things in here that I highlight. I'll even link back and remind them of specific lab activities that they did to give them experience in these things. And then I'll also point out some of the jargon, non-conformance investigations. So you might not know what that is now, but that is also something that people are capable of learning on the job. I also like to point out that I don't like that the first line says conduct experiments to prove hypotheses. Anyone else have a problem with that? Good scientists try to disprove hypotheses, but that's just me being nitpicky. But a lot of the things that we do in the course are actually helping them practice implementing statistical techniques, implementing documentation, generating protocols and reports. They are designing test protocols, they're collecting data, they're analyzing this. So I also encourage them to think that they should feel qualified for this job. Along with that, I also like to just talk throughout the semester about what sorts of jobs are available for entry BME. So Cassie Jameson had a pretty good paper where she looked at entry-level jobs. This was done in 2021. Looked at roughly 100 jobs. It wasn't exactly 100 jobs, but the numbers almost kind of correspond to percentages. But 44% of entry-level jobs have some sort of quality engineering in it. So I do describe what is quality engineering. I describe why is it that we're doing specific labs that are similar to quality engineering, but also linking back to these other skills related to technical communication, research skills, and being a collaborative team player are all really highly desirable in entry-level BME jobs. So this isn't just constrained to this one class that I teach. I also am currently teaching a new version of our Anatomy for Engineers course. So these are sophomore level students. And this semester I showed them this example job posting. So this is for an airman accommodation lab. We are about 45 minutes away from an Air Force base that actually does a lot of like anthropometric data analysis and research related to kind of like human systems. So I point out some of these. I actually did not highlight anything for them when I showed them this, but I let them read through this assignment. I'm highlighting things for you because what I did was when I was designing this class this summer was I was looking at job ads and trying to pull out skills that people hiring our students will want. So the things that I highlighted here are things that I specifically tried to make course activities related to. So some of that is measuring on real humans, kind of quantifying variability of human subjects, doing some data analysis, and also 3D software programs for digital human modeling. There was another job ad that I found that specifically related to segmentation of medical images and how that can be used. And essentially just trying to find jobs that are really using this anatomy knowledge to try to motivate students to learn this information. So there's this surgical preview software that is used to go from MRI images to 3D digital models in order to help surgeons plan for surgeries. So I actually tried to recreate some of this idea in two different assignments throughout the semester. So one example lab activity that we did this semester was for a mini project where students are supposed to analyze a joint from CT images and make a recommendation for a prosthetic replacement, be it size. So we actually found some documentation from Zimmer Biomet that actually describes the size of the joint versus the size of the prosthetic replacement. So one of the lab assignments was for students to use medical images going from these CT slices. So part of it is understanding what those medical images are, but then using a specific software to do image segmentation. And for their first one, it was relatively simple. It was actually almost barely you could call it segmentation, because they were just creating one model of a bone, but they were able to get a 3D digital measurement of bones for joints and make measurements to kind of inform their decisions on how a prosthetic replacement would fit. We also did kind of building on those segmentation skills, working in the cardiovascular module. I had students use this ITK Snap software to segment the heart. So in this case, they're actually imaging multiple parts of the heart to create a more complex 3D model. And then they can import that into their favorite CAD software to take digital measurements. So we're kind of limited on, what sort of human measurements they can make, because we don't have human cadavers. So they can make physical measurements on porcine hearts in the lab, but then they can also compare them to 3D digital measurements of humans and relate that to specific pathologies as well. So they're using these engineering tools to learn about anatomy and relating that back to, again, how are these actually going to be used in biomedical engineering careers? So I often actually get kind of unsolicited feedback about this from students in my student evaluations of instruction, so my end of semester sort of evaluations. And part of, I think what's helpful is like the process of looking at job posts for me to decide what I should put in my course. So I'm using this information to design course objectives when I do design a course. And so a student wrote, Dr. Childers sets up a course that focuses on learning tasks that will be directly applicable to future careers in industry and grad school, and specifically appreciated showing how the course objectives match the job descriptions. Again, a second goal is just to kind of like bring up different job titles, because if you search for biomedical engineering, you don't often get all the biomedical engineering jobs. But it also can communicate the relevance of skills to the students. So the first time I taught my upper level lab course, I used to get some comments that were like, this class just teaches me research skills. I don't care about that. I want to go into industry. And so now I'm more like intentionally directly linking about like, even as an engineer in industry, you still need to have these research skills, right? And then other students have also made comments about how this actually motivates them to learn the content. So seeing in the beginning of the course an entry-level job and its qualifications, being able to see the relevance of what they're learning, and also translating, so seeing it again at the end of the class. A lot of students are surprised by how much they've learned. And it actually can help them kind of put into words what they can translate to their resume, or how they can actually translate it to talking points during an interview. So a student pointed out that it helped them see the relevance of the skills that they learned in class. And then finally, it's again kind of building on that idea of like really realizing how much they've learned, building confidence that they now can apply for these job types. So that's kind of just the examples of some ideas of how I've incorporated this. And I would love to hear what you guys think, or ideas to do it better, or whatever else you guys want to talk about.